Alright, this time on Captain Chaos's Laboratory, we're going to be working on a Mr. Christmas Santa's Marching Band. Here's the back cover, so you can try and read it. There you go. Came as this piece, and the control box separate, which plugs into the wall. The reason I have the back off before I started was these plugs plug into this big circuit board. And what I was told was that some of these work and some of them don't. And the person that sent it, her husband already tried to do some repair, which is why like that guy's not attached or this guy over here is not attached. And it did arrive with some parts in a baggie, and one of the little dingers right here was laying in there for this guy. So I've got to figure out how to reattach that. So we'll start off by seeing what this thing does. Now this plugs into the wall and it's high powered. Here's the step down transformer. So there's a lot of juice in here. So if you have this and you have to open it up to do something, be careful, make sure it's unplugged so you potentially don't electrocute yourself or shock yourself really bad. That could be a bad day. So plug them in. You can only plug them in one way. Try and plug them in backwards, they won't fit. Technically, you should put the cover back on for safety. These wires run down right here, and there's a hole. And then it has little zip ties for strain relief, so you can't yank the cords out. These are painted. If you look closely before I plug this guy in, you can see the paint is worn off on some of these, and you can see that there's blue or red, black, yellow, purple, and well, green. There's one green wire in each one. So just stand them up, except for the ones that are unhooked. And let's make sure the switch is in the off position, which it is. It's right there. I have no idea how loud this is. We're going to find out here in just a moment. It's plugged in. Interesting. Okay, let's turn it off. Let's unplug it for safety. Be careful, even though it's unplugged, there's a chance that this may still have power. And the reason I say that is it's got two really big capacitors right here, which may or may not have a discharge resistor. And you don't want to stick your finger there and find out that it doesn't, because that could give you a bad hair day. So this is apparently one of the ones that's weak, and it's not working right, and it's been partially. So we'll start with this guy. It's a lot of wires, and I don't know if this top slides off or not. Probably not, but there are a couple screws in the bottom. There's some rubber pads. Two of them appear to be missing. One of them appears to be still intact. Let me see if there's a screw under there. It makes sense that there would be. And there is. So the problem with it is like I said, a couple of them aren't smacking the bells. They just don't have enough oomph to swing and hit them. And the lady that sent them to me said it's a favorite toy of hers and she'd like her children to enjoy it. I have, well, not toy. Technically, none of the stuff that Mr. Christmas makes is a toy. But, yeah, it'll be interesting to see if we can get this functional or not. So I took the three outer screws out. Now I'm taking out the center screw, which I don't know if it holds anything in the drum on, but it does hold on the bells. It's kind of interesting that you can actually hang these as well as set them on their feet. So you can set them up on a table or hang them in your Christmas tree. So the 3 screws are out, plus the center. There is a screw in this upper center, so I'm going to take that guy out too. And drop it on the floor. I'll get that in a minute. Okay, so we have a little motor that drives a gear and uses a spring on this piece of plastic to reset it back to center. That's why it jerks so much. So either the motor is getting weak or the spring. We have 2 stoppers right here. I'm going to try and get this closer to the camera. So here's the motor gear. Here's the motor bottom. Here's the spring. And then these are the rubber stoppers for this. And I'm assuming these little wires that go up to the guy on the top is because it lights up. Would make sense because all of them have a clear piece on their hat. Now we just need to figure out how to get to the bottom. Put the spring there so I don't lose it. Check this big gear. Make sure there's nothing wrong with it. This gear here isn't plastic, so it's probably not broken. I'm going to check the teeth. This is a brass gear. It might even be metal that's just painted. Let's find out. No, it's not magnetic. So it's most likely a brass gear. And it looks all good. Now, let's see if we can get this bottom off. If it's a weak motor, it's probably a standard 3-volt hobby motor. But we need to open her up to find out. Here's a small screwdriver. See if I can get the drum body to separate. It doesn't want to separate. It's acting like there's something still either clipped or screwed. There's no screws, and I don't see any clips. You know what? Let's just pop this spring back on and see if maybe we can hear what's wrong with this one. I'm not going to screw it in. It shouldn't fall out. But what I am going to do is disconnect the other string. So I'm only dealing with one string at a time. Convoluted mess of wires. plug. Alright, let's plug it in. Yeah, and their hats do light up. Alright, apparently I unplugged the wrong one. That's not a big deal. Plug in the right one and disconnect the other side. There we go. That turned pretty violently. It's only turning in one direction. It's turning this way, but when it tries to turn this way, it stops. The reason I know it's trying to turn is I can feel it with my fingers every once in a while, and I see his hat flash. I have no idea what song it's playing, though. Yeah, it won't turn to one side. Whatever this song is trying to turn it the other way. So just going to check under the stopper here and see if maybe there's some hidden screws. So I'll pop one of these stoppers off this one that's at an angle and see if there's something hidden underneath it that maybe will allow me to get the bottom off. And then I can voltage test the motor. Nope, it's just got a plastic pin that this is pushed on and then glued. So I'm going to remove the spring again so it doesn't shoot off and disappear. Because that would be Murphy. I don't know how many of y'all seen this one before, but this is the first time I've ever seen it. What I'm doing is I'm using magnifiers and looking down the smiley face groove for the wire to track in to see what I can see. I don't see any releases. I see the motor. It looks like it's just glued in. And that's all grease. I think I got grease inside the motor. I can see a slight space in between where the drum tie downs are, but I don't see an actual space underneath. I'm thinking the red separates from the gold. Ah, there it goes. It does. There we go. Look at that. So, the gold bottom, the center screw doesn't actually come through. The center screw goes into a blind boss, which is just to hold the bells. So, Technically, you don't have to take the bells off unless you want to have them out of the way. I'd recommend not unscrewing the bells just because they're probably tensioned to give you the right tone. Now, unfortunately, this stuff here is really brittle, probably because of its age, and it's coming apart in pieces. You could technically go to a craft store and rewrap it. You can get little gold twine. Alright, let's unplug the power. So the red and black wire is the motor, which comes off of this little circuit board right here. I'm going to pop it up off of its pins, and we're going to check. On the other side of the circuit board, we have 4 diodes and 1 resistor. 3 of the diodes come from the incoming power on the green wire, incoming / outgoing. The resistor goes to the light in the hat, probably because it's a low voltage LED or a low voltage incandescent. And then the other diodes go to the red and black wire because it reverses polarity to make it swing left and right, left and right. So I don't backfeed anything here. I'm going to unplug this, and I'm going to send a couple of volts through that motor and see if I can get it to spin both directions. I'm going to start off at 2 volts DC. And I'm just going to touch the motor directly. Not enough juice to make the motor turn. I'm going to bump it up to about 2.5 volts. Alright, I'm just going to take the motor out, see if it has any information written on it. The motor is full of grease. That's probably why it's not working right. It's the main leading cause for motor failure. Just wiping off the grease off the back of the motor and trying to read what it says. Just tells you the name of the motor company. There's no stamps on this motor whatsoever to tell me the voltage, but there's grease inside the motor, which is not good. These electric motors don't like grease. It's a very common issue on Lemax. The way they grease them, it runs inside the motor. The grease in here got warm enough to drip inside at least this motor, possibly the other ones that are dangling. This guy right there. So I'm going to desolder, and then I'm going to test it again, but then I'm also going to plug it back in and put a voltmeter on here and see if I can catch the voltage. This is one of the reasons why these videos take so long is there's a lot of stuff that needs to be checked, and it's a process of elimination. Just desoldering one side. I'm going to guarantee is that there's no continuity through the actual circuitry. And now I'm going to test it again. Well, I took this up to 7 volts and I'm getting nothing. Just going to reverse the polarity and see if that's maybe the direction it's having the issues with. 3 volts. 4 volts. 6 volts. Alright, just try it again. I might have had a bad connection on the voltmeter. So, there we go. It does turn. So that's 2 volts. And I am spinning. Ooh, that sounds horrible. I don't know if you can hear the squeal. That's one direction. Let's try the other. At 3 volts, this thing is pulling a half an amp. Whew. That is a lot of juice. The other direction is pulling 400 milliamps. So now I want to test the voltage that's coming to these 2 wires, or try and capture it. The problem with that is that sometimes it's hard to catch on a digital meter because there's a delay. We are going to try. And I'm going to see if I can capture the voltage that's coming through. That way I can make sure if I have to replace these motors to test them, that I can get one that's in the same voltage range, because if it's not, it won't move as fast or as efficiently. Probably also helps to plug it back in. I don't think this one's been hit yet, because it's not changing voltage. So far the voltage is only fluctuating by half a volt. I'm going to turn him around so I can look for the flash. Oh, I plugged the right one in again. It would be stupid if I didn't. Yeah, I did. Should mark these. Yeah, I saw his hat flash. Now this piece of music doesn't have him flashing too much. It's all over the charts. I'm not getting a good enough capture. It's ranging from a half a volt to 220 volts, which I know is wrong. So, let me see if I can find an analog meter. Analog meters are sometimes more accurate on rapid changes. Sometimes. No, this one won't work. Well, I'm going to try and find an analog meter. I thought I had one in here, but the one I have is for AC only, and we're working with possibly DC. Well, definitely DC. Well, I'll be back in a few, see if I can find what the actual voltage is coming out of this thing. I shall return. Alright, I'm back. I can't find an analog meter. I know I have one, I just don't know where it's gone. But what I did is I have a clamp, as you can see here with the alligator clips, going to my power supply. My power supply, if you flip a switch and move a lead, it'll tell you the voltage. And it's kind of hard because it only works in the positive direction. It doesn't give me negative voltage. But watching it for, I don't know, 3 songs, I'm going to guess based on the how fast it was dinging and then the pauses in between. The peak that it hit on the meter was 7.2 volts. Not 220 like the other meter. It's because it's a rapid burst of energy, so it swings really quick. And the problem with that is digital meters have a delay, as I was mentioning. Analog meters don't generally have as much of a delay. They still do, don't get me wrong. They still have a delay. So this is most likely either a 9 or 12 volt motor that works in both directions. And the problem it's having is one of the directions is probably getting weak. What I'm going to do now is I'm going to solder this wire back on and leave the motor out. And now that it's not encased in plastic, there's a chance I might be able to hear it or see it's not spinning as quick in one direction or it's having an issue, meaning that it's jerking. Because without a load, meaning the motor itself having one wire disconnected, it'll give me the peak power, but it won't give me the issue with the motor. And then right after, actually while my soldering iron's heating up, let's do a continuity test on it. See what the windings are at. 3.2 ohms in that direction. It should technically be the same in the other. No, it's going up. Probably helps if my finger didn't slip. Let's try that again. So in the other direction I got 2.7. So there is a little bit of a variance in the coil. It also could be the capacitor on the top. Wow, it's just all over the place. 3.3, 3.4. That's pretty standard for most motors in the threes. Alright. I honestly believe that the motors are getting weak, probably because they filled with grease. So, I'll wet my tip. And we're going to resolder this wire on. Whoa! Hear that squeal? The only slow part is you have to wait for whatever two notes he plays to be activated. It'd be interesting if this... Yeah, that sounds horrible. Also, it's vibrating really bad. These motors are generally really smooth. So I believe we found the problem. We probably just have a bad motor. Several of them, as a matter of fact. God, it sounds so bad. Hopefully the camera picks it up. So now I need to see if I have some of these that have a 9 to 12 volt range. Because there are 3 that are disconnected. One here, and this guy. But this guy, I got to get his little bell beater back on. The plastic is broke. So that's going to be interesting because the amount of force you can see these things hitting with, I don't think super glue or anything is going to hold it in place. I think it's going to hit once or twice and then throw this off into the next room because these hit pretty hard. So let's work on this guy and see if we can change this motor and then put it back together and see if he swings properly. If he does, hopefully I have 3 of these motors and I can do the other 2 and we can set this all up and see what kind of bell music it plays. So, as always, Make sure if you're working on something that runs on a lot of power, meaning it doesn't have an inverter at the wall socket, it has a standard plug. When you're not using it, unplug it, especially if it's exposed like this, so you don't accidentally hurt yourself. I don't know how many of you out there have been zapped, but it can be very painful and it can have lingering effects for hours. Or in the case of myself, I got hit with 240 volts and it stopped my heart and I had to be jump started. That happened many years ago. So you got to be very careful with electricity. It is indiscriminate. It doesn't care who or what you are. If you do the wrong thing, it can end your life. So just like I stressed on a 120 volt carousel, make sure you're safe and that you unplug it when you're servicing it so you don't end up in the obituary column. So, all right, I'll be back in a moment. I'm going to see what I have for these little hobby motors. These are standard hobby motors. I know I have some hiding around here somewhere. I got to check their voltages and make sure they're within the proper range. Because if you put, let's say, a 6-volt motor in here and this thing gets 7 volts, it's not going to burn the motor up immediately or anything because you're only going over the voltage by a small fraction and for an instant. But it does mean that the motor will spin faster, which means it'll smack harder and possibly out of tune or time. So I'm going to see what I have. Most likely it will not have a metal gear on it. We're going to see if we can pop this guy off and swap it over to the other motor. And then the case with the two over here. So we're going to see. And in worst cases, I'll have to put the smoothing capacitor, which is a little orange thing here, onto the other motor. Because not all motors come with this. Usually motors for most hobbies only spin in one direction, not both. And that's probably why they have that there. So I will return once I find some motors. Alright, I am back. Here's the old motor with the metal gear. You can see the deflection on the shaft. You shouldn't do that. That's why the motor's going out and getting weak. I found one, which means I'm probably going to have to order another one for these, because these motors come in different sizes. Height, width, length, nose, tail. There's a half a dozen measurements that you can find for these motors. The one I have was designed to run at 3 volts continuously. If you run it above 6 volts continuously, the motor will start to burn. It's a 5 to 6 volt motor. I used a 10-tooth plastic gear because I couldn't get the metal one off. The metal ones are always hard to get off. They're usually crimped on or pressed on or sweated on. But I wanted to use a plastic gear to test it. And I put it all back together. And you'll see here, it's this guy here. He moves in both directions now. I'm holding it down because it's not screwed. You see that? Now he's moving back and forth violently like he's supposed to. That's the problem with this and those two over there. Besides, this one has a broken wire for the lights. Is the motors are weak. So let's see. See, back and forth. Look at that. Do it again. Come on. Maybe you'll be able to see his light light up. Let me turn off the extra light. Apparently it's the piece of music where this guy doesn't get engaged a lot. So we'll turn it back off. It should reset back to the beginning. Okay. There's a little red light in this hat. I don't know if you can see it that quick or not. So that is the problem. The problem is the motors are weak. Probably because they got grease in them. So we're going to leave it right here. I'm going to do some more searching for more motors. And if I can't, I'll buy some, and we'll get this thing fixed up. But there's the white plastic gear, which at the rate that this thing spins back and forth, this gear is going to lose its teeth or crack. So, but it was just a try. It's just to do a proof of function, since this is bad, and I can't get this off. What I'll probably do is just pull the armature all the way out and see if I can pry this gear off without damaging it. If I can, I'll press it onto the other one, hopefully without damaging that one. If not, I'll see if I can find these motors with the gears pre-pressed, because I've always had a problem with the metal ones coming off. So, but there's the malfunction. The reason this isn't working: bad motors, probably full of grease. So I'll leave it here so I can find some motors, and if I don't have any, I'll buy some. I'm not sure what these spare parts are. That's a broken piece of plastic, and that's a spacer disc and a screw. It might be from one of the other two. Or that broken piece of plastic could be from this guy, since it's actually, well, broken. So anyhow, that's where we're at. And now I just need to locate some motors and rebuild the other two. So once I have those, we'll get this finished up, do a final check. So, see you shortly. Alright, I wanted to show you, before I take them all apart and finish fixing them, how to swap out these motors. And I'm going to put a link below on the tool that I use, as well as where to get the motors from. Okay. So, first thing, you can see that they're soldered. So you need to break the solder free. So, easiest way to do that is put some fresh solder on it. Now all the solder I use is lead-based. And the fresh solder allows the transfer of heat and helps break down the old solder. And then with a little tension on the wire, they pop right off. So this is the tool that I use, and there's already a gear in here. To remove these metal gears that are on the end of these, you can either heat them up and pop them off, or you can use a gear removal tool, which this uses a slide bar, which has two different grooves in it, you can see, that are different sizes to fit around the shaft. This has got a notch in it and a screw, and it's basically just a miniature press. But these little gears don't like to come off. So you stick it in, you screw the pin down to where it goes in the center of the gear, where the hole is. Hopefully you can see that. It does come with different size pins. So if your hole is bigger or smaller, use the appropriate one. This little metal bar, you put it in here and you just turn this. And what that does is it presses the armature out, and you have just your gear. There you go. Gear's off. So now you just spin this back. Try not to lose your pieces. There we go. And that easy. There is the pressed on metal gear. Now to press the gear on to the new motor, so I'll grab one of those. I would recommend a vise. So the one side of the gear has a big hole, the other side of the gear, well, they're technically the same size, but this one always looks bigger. Anyway, if you try and push it on, you can't push it on because it's a pressed on part. Now the armature protrudes out the back. You need to keep equal pressure on it. You need to do a clamping force, a square clamping force, only on that metal piece protruding. Where if you use a pair of pliers, you might be cocked at an angle and you'll end up bending the armature. You can try and tap it on, put this metal pin that sticks out the back, which is the other end of the armature, and tap it. Same problem, it might go on an angle. Whereas a vise uses straight clamping force. I have a little clamp-on vise on my bench right here. That's not a bolt-on like on the other side. let me see if I can unclamp this and show you how to do it on camera. Well, that came off way easier than I thought. See if it opens far enough. A little more. So, I'm going to stick it in the vise, and I'm going to close it and try and make sure that the motor is parallel to everything. It's easier when it's bolted to the bench, I'm not going to lie. But I'm trying to show you. So, it's in, and then you just start closing it, and it represses the gear on. Open it back up, and there you go. So you can see it's on, it spins, it is recessed like it was before. It's recessed just the, I don't know, 64th of an inch below the surface, and it spins in a circle. And if you want to check to see if you damaged it, you can take a battery. So I'll just take a battery, and you can touch the contacts to make sure that you can hear it. So if you don't have a power supply, you can test these on a battery, and then you can see it's spinning in perfect circle versus being all wobbly, meaning you bent it. So that is the easiest way to remove and re-add the gear when they're metal. I would recommend a removal set, and then I recommend a vise. You can get little jeweler's vices like this one that I have clamped on the end of my bench, or I have a bigger one because that one's on this side and it's clamped on the far end of my bench, and I use it because it has a flat jaw versus a serrated jaw on the inside, and it has a very small anvil. And the one on that side of the bench is a much larger vise, which has a much larger anvil, which is the back piece, and it has a serrated jaw for holding stuff. Both of them work perfectly fine for this. But if you do get a small one, you just need to make sure that the jaw is open wide enough to compress. Vices aren't overly expensive, and if I find one on Amazon, I'll put a link below. That's a decent price, since it's the easiest way to press them back together. So in previous videos where I've talked about pressing stuff with the vise, that's what I'm doing. When I'm off camera pressing something with the vise, I'm actually using it as a square jaw to squeeze things back together, because a vise can put out approximately 10,000 pounds of force, depending on the size of the vise and the twist bar, or the bar that turns it. And then you can do stuff like this. The plastic gears usually just slide on, put them on with your hand or thumb, what have you, but the vices work great for the metal ones. So the one I did put together a few moments ago, here's its metal gear. So I'm going to swap off that plastic gear for the metal gear, and I'm going to put this one back together, and then I'm going to try and figure out how to fix this knocker, because yeah, it's broken. Then we're going to put it all back together. I'm going to set it up in a line, and we're going to see if they work. So I'll return momentarily and figure out if we can fix this knocker, and we'll go from there. I want to show you how to remove and reattach a metal gear on a hobby motor using an inexpensive gear tool and a common vise. Again, they're not that expensive. That clamp-on vise, I think, was like 20 bucks. The bolt-on vise was like 80. But it's a much larger vise, like I said. It's right here at the other end. And if you have a shop or garage, that's usually a common tool that you might have in the shop or garage. If not, if you can get some square compression pliers, those will work too, but you got to make sure everything stays square and not parallel, or parallel but not at an angle where it's perpendicular or sloped. Like these, you can see they open at an angle. They're not square and they don't close as a square. So That's that. I'm going to get this guy back together real quick, and then we're going to work on seeing about repairing this dinger, see what I can do to maybe make it work. And then we're going to fire this thing up and see if it functions like it's supposed to with 3 new motors. So, be back momentarily. Alright. After replacing 3 motors and trying to readjust these bells because they're all bent in different places, trying to get them so the hammers actually hit the bottom of the bell. I got most of it. I think some of the bells might be slightly out of tune. It might be because they're bent or distorted, like this one's bent forward, this one's bent backwards. I've been trying to center them all. I fixed the broken dongle, or bell smacker, whatever you want to call it, bell ringer. I just used a heavy-duty Gorilla Glue it melts the plastics together. So, and it's holding. I've been testing it and trying to tune the bells. Like I said, because they're not hitting in the right spot. They're either hitting too high or some are missing altogether. But after several minutes listening to this thing ding a lot, I think we got it. So let me turn it off for y'all. All I gotta do is put the cover back on, and I think she's done. And here some of them have a tinging sound and some of them have a solid sound, and that's what I'm trying to adjust. Like this bell right here is solid sounding, like it's not moving. But these like to walk across the bench as they get more violent. There's a lot of songs. So, turn it off since it's probably getting deafening on your computer speakers because it's such a high-pitched sound. Also, I've only heard them play the same pieces of music a dozen times while I'm trying to adjust the height of the bells. These little brass arms, a lot of them are distorted, and ones that ting, and I've been trying to do it with, to see which ones have the dead sound, that one. And I don't really want to unscrew it, I just try to turn it a little bit to see if it adjusts the tone. Because they're all different notes. They're all different size bells. But, yeah, see, that one's got a dead sound. Ting. Ting. Dead. So, I think that's part of the problem as far as the noise goes. As far as I'm smacking everything now, I have them all pretty much in alignment. It's got a little bit of a ting, but it still sounds dead. So, I'm not sure if this came with tuning instructions on how to tune the bells. This is a really old piece, so it's hard to tell. But I did notice that some of my bell issues were these arms are all distorted. A lot of them were folded or kinked or pushed in, pushed out. So I've been trying to go around and do them after I placed all the motors. So 3 new motors with the gear swap and using the heavy-duty Gorilla Glue to reattach the bell knocker right there. And using that tool I was showing y'all, which is in this baggie, to swap the metal gears. I got the glare. There you go. I think we're good. I think we salvaged this thing. I mean, it's old and it's still functional. Just got to figure out how to tune the bell so you get the tinging sound in all of them and not that dull thud on a couple of them. She does seem to hit the majority of the bells almost all the time. There is a couple times where it misses, and the signal coming from the box isn't as powerful. So I think that the signal being sent is too fast or too weak, which means that possibly one of these components is wearing out, probably one of these two big capacitors, example. But it only misses it on like song number 7, where it's moving so fast, and it might be that it's moving so fast that because these flex, as you can see, they're on springs, it's not hitting the bell when it's on its way back. So basically the inertia is so fast that it's going this way to hit, and when it goes to hit, it's already moving the other direction, so it just grazes the bell. So you don't get a very solid ting, you get a very mild ting. And maybe it's supposed to. Maybe the ting is supposed to be milder for the music. I'm not sure. I've never seen this before in my life, and it's kind of interesting that they would have something like this where you could hang up, 7 of these? 1, 2, 3, 4, 5, 6, 7, 8. 8 of these things on a tree with these hooks, or on your tabletop, and have them play music. The wires are obnoxious, I'm not going to lie. You'd have to stretch the wires out as far as you can so they don't keep interfering with the clackers. But if you hung them on a tree or a rope or a line of some sort, they'd be pretty good. But they do bounce around violently. There's a lot of inertial torque on these. These motors are going from 0 to about a full revolution to back to 0 to the other side revolution, or they go just half and half and half and half and half, which is just smacking one bell. So there's a lot of torque on these little guys. The motors that I'm using, like I showed you before, are the same hobby motors with a 6 to 12 volt rating, because the voltage I was getting out of that box over there was right around 7. It was averaging out between 7 to 7.8. So I didn't want to go with a motor that's too low, and I didn't want to go with a motor too high, because the higher the voltage, the slower it's going to turn. The lower the voltage, the faster it's going to turn. And if your voltage is way too low, like you put a 1 volt motor in here, a 1.5 volt hobby motor, it's going to burn. You're going to smoke it. It's going to destroy the motor. So if you have this piece from Mr. Christmas, try and get yourself a replacement set of motors for right around 6 volts. A little under isn't going to hurt it because it's not constant voltage, it's just pulsing it. So it's just going smack, 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 versus spin all the time. Like I said, these are rated 6 to 12. Below 6 volts, they don't have any torque or speed. Above 12 volts, they'll just start to burn the coils. So with this thing pumping out nearly 8 volts at its peak and 6.5 volts at its minimum, it's within the range. I was trying to find a 9 volt top end motor, but I could not find any with the exact dimensions this thing took. So if you are going to do this and you have this or something similar, and dimensions are important because that motor is sandwiched in here and it's held in by this piece on the bottom, which has got a flat spot to match the bottom of the motor. You see that flat spot right there. That motor can't be any taller because the sandwiched spot is here. It can't be any wider because it's got a little 2 shoulders that stick down that it fits in. And it can't be any taller, or else it's going to, on the shaft, because it'll rub the plate. But if the shaft is too tall, you can cut the shaft. You can trim it down. So like I said, I used the micrometer, which is right here. I'll link this on Amazon. It's not a big deal. That's where I got this one from, because my old one's dying, which I got from Harbor Freight. It's a little bit better quality. It's a lot heavier, and the off-on button actually works like it's supposed to, whereas the one from Harbor Freight, you turn it off and it turns itself right back on. So, and it should turn on when you move this, which it does, and it should go back to 0, which it does. The Harbor Freight one turns on, but doesn't go back to 0. So this one I like better, which is a Vinca. So I'll link this on Amazon for y'all if you're interested in getting a micrometer. So you can measure the motors as they come in different lengths. And on most of the listings for the motors, they'll tell you the length of the body, the length from the shaft to shaft, and they'll even tell you the height in the width. So there's your width, and then your height. Hopefully you're not getting too much glare. And then they'll even say that it's a 2 mil or a 1.5 or a 3 mil shaft. That's a 2 mil. That's why it says 1.99. So micrometer comes in handy if you're going to fix your own, and they're not overly expensive. You can get good ones for 20 bucks or less. So you can use the old school analog type where it has a big needle that spins and calculate it down using math if you want. Digital ones are nice. They're just faster. I have both digital and analog in case the batteries die. This takes those button cells. So what this took to do it correctly was a set of motors, a micrometer to measure the motors, and then the tool to separate the ends of the motors. So that way I didn't damage anything, because the other option again is you actually use a torch, propane, MAP gas, etc., torch, and you heat the end of the motor up that's bad. You heat right where the gear is so the gear expands and you can slide it off. That's great and all, but once you slide it off, you got to make sure that you don't distort the gear. It is just basically a brass gear, and well, they can melt and distort. That's why I don't like using the heat method. Now on a car, when you're pulling gears off a car, heat's fine. Those gears are massive. They can handle it. These are itty bitty little guys. And a vise. Like I said, to press the gears on, I'd recommend a vise versus channel locks or pliers, just because the vices, the jaws are parallel, so you're guaranteed to get a parallel. Unless your vise is bent, you don't get a guaranteed compression. And with it being open completely, you can look down and see that it's going in square, it's not cocked at an angle, and you can see how far in it goes so you know where to stop. So, but I'll link it all down below in the video description down there somewhere, right in there. The links to the motors, the tools, everything I used. I am going to cover the casing up since it's still plugged in, and we're going to get this thing packaged a little bit better because it's now together and 90% tuned. Again, I don't know how to tune the bells, so I got it to where all the smackers hit the bells on the flat parts and not up high on the tapered parts, and not miss it completely. But I hope she has the instructions so I can send this back to her so she can tune the bells that sound dead, which I think there's a total of 3 of them now that have that dead sound. So hopefully this helped and it was interesting, and it's something that you've never seen before, where you have the Mr. Christmas Marching Band, where you have 7 marchers and 1 Santa Claus playing different music on the bells. Till the next one, have a good one.